mSATA and with the battery backup itself. I have the mSATA SSD shield, and of course I have an SSD M2 drive here as well. I have this battery pack that we will incorporate as well, and to get them together we need to sandwich this. So we have this on the bottom, this in the middle, and this on top like that. And the gear that we got with SATA shield is not enough doing this. I mean, we can potentially use this one like that and then attach the shield underneath like this, and that will look fine and most likely work fine for that one. But we need something on the top to hold this one up like that, and that needs to sit a little bit off the Raspberry Pi. Kits like this one in plastic where you have different distances, I will link that down below so you can get yourself a couple of kits like this if you want to build. So I'm going to use this one here because I tried with those here and the one that I had, the other one, and it didn't fit that well. So I'm going to use these plastic ones. How close can this one sit? Not closer than that. That means they will fit just fine. And depending on the size of these ones here, you might need to drill up the hole. I'm using, I think it is M3, they are a little bit big, but the M2.5 I think are a little bit fragile, but you can get either some. If you get the wrong one, you need to take your drill and drill the holes up. This is really not a problem. You don't destroy anything on this board, so that's not an issue at all. And then we have the battery pack itself. Yeah, I'm going to put it like that. I need to install the drive. Then you take the drive like this, slide it in, press it down. So what we need now, of course, I'm going to use the card as well, the SD card here, and that's because I can run the OS on this one. I'm going to run the OS here and the data on this drive here, making that possible to run the database and logging and everything on this drive. What we need now, we need to power this board, and that one is powered from this USB micro, and so is the Raspberry Pi. It's powered from the USB micro. You charge it via this port here, and then you have two outputs here, one to the mSATA drive and one to the Raspberry Pi. So let us get some cables for that. It's time to add the USB cables between it, and I bought a couple of them. For instance, here I have a USB to micro USB. So you basically have to insert this one here, and this one goes around to the Raspberry Pi. We need this USB cable here that attaches the mSATA shield to one of the USB 3.0 ports. So we have everything wired up now. We can potentially just flick this switch and it will turn on like that. So if you look, you can see that it is reading green and red. That means basically it's trying to read from the card now, but it can't because we don't have any SD card in. So there is though one problem with this setup here, and that's when you switch from, for instance, powering from an external source like this power bank or the grid, and it switches over to the battery, this system is not fast enough. it's a cheap battery bank solution, and it kind of works, but it cannot cope with the load from the Raspberry Pi 4 and the mSATA itself. This is a known issue that many people have reported. So let me show you how it looks like, and let me show you how we can fix it. First of all, I'm going to hook up the oscilloscope, and you will see it on that one. So let me do that. Here we can clearly see that I'm measuring and that we have 0 volt currently. So let me turn on the battery bank, and you will see that it jumped up to 5.2 volts. And when I insert the battery bank, it switches down to the battery bank power that is around 4.8 volt instead. It's a little bit low and a little bit ripply. But it do work. The reason for that voltage drop is the cable I'm using between the battery bank itself. So, if I now switch back to the Raspberry Pi's battery source instead, let me do that and go to single mode and capture it. It will look like that. And that's not really nice. So as you can see here, we are down to around 2.5 volt at minimum before it starts to boot up again, and it goes up to 5.2 volt when regulated. So this is a big problem, because this dip here kills the Raspberry Pi and reboots it. You can live with it, of course, but if you have a lot of blackouts, this will tear on your SD card and might even corrupt it. So how do we fix this? I mean, buy a better battery bank, but I have this cheap one here. So what I'm going to do is that I'm going to add a couple of capacitors on the input side of the power to the Raspberry Pi. In my case, I mean, dependent on what you're drawing, you might need different sizes of capacitors. I know that I need around 2000 microfarad. And this is to 1000 microfarad, 25 volt. Unfortunately, I don't think I have anything else in this size. You can use 10 volt, 5000 or something like that. You should be able to gather those from computer PSUs and other stuff like that. So just check your scrap pile and get some. To do this, we need to pick this apart, and we need to add the capacitor somewhere inside. So let's do that. As you can see on the underside here, we don't have much capacitors here. I mean, you have the small ones, but nothing really big enough. And since this switches over in a time frame at about 2 milliseconds, and that's more than enough for this Raspberry Pi to shut down, because the Raspberry Pi itself does not have any capacitors either. So we're going to add a couple of capacitors here. We're going to measure to make sure that we know which ones are the positive and negative voltage, and I'm pretty sure that's negative and that one is positive. There we have 5.2 volt on the output rail, and the same there. So let's add the capacitors. So let's pre-solder them. Solder there. We can add some solder to the negative as well. And I'm going to add it like that. So we need to cut them off a little bit. That's one of them. Let's add that one like that. Just make sure that you have the positive and negative correctly. So as you can see, negative, negative, go to the negative side, positive to the positive side. And this potentially upgrades this board a lot, I would say. So let's fasten them with some hot snot, of course. So we now have our newly modified board that is 10 times better than before. So let's put it back again. Just make sure that it actually fits after this modification, and it does. Add all cables up again. The oscilloscope back up again. Single. And we don't track anything. As you can see, there are a little spike there still, and it doesn't actually harm the Raspberry Pi. It's so small that the Raspberry Pi can cope with it. But for you guys, if you need more power, add a big capacitor. But the mSATA board itself in this setup is the big disadvantage. So let's hook this one in. Let's insert the battery itself, like that. Start the battery up and hook up the external source. It's now booting up again, and the SD card is pre-prepared like I did on the first build. Let's see if we can ping it. We have the address there. Let's cross-check that we have the disk aligned as well. And as you can see here, we have the SSD drive and the M2 SATA drive actually attached, and it seems to be working just fine. So let's format it and add it to the file system. First of all, let's add a partition, and we want a new primary, and we right click mkfs for dev. Now we are writing the new file system, and let's add it. And mount it. And here we have the new file system, and it holds nothing on it right now. And it have around 111